one. You know, we're going to take more than one day to do this particular lesson, but we're going to start with, our learning goal today is I can translate between words and algebra. So in other words, I can replace words with some algebra stuff, or I can take algebra stuff and I can replace it with words. I can go back and forth between them. I have an understanding of them. It's kind of like translating between languages, right? How many of you are in Spanish? Anybody? Anybody ever intend to take Spanish? Yeah. So we have to translate between languages, right? If somebody speaks to us in Spanish, we're going to have to count on Blake here to translate that for us to our English language. He says no, not yet. Okay. So let's start with the vocabulary. We already, so this is like another chance to write it down, and it's going to go into our memory for the but we're going to put it in our own words. Try to, okay? So anybody think they have a good definition for a variable that we can write in our notes? Yes, I'm going to have to do it, huh? Okay, a letter used to represent, get that much down, a letter used to represent so from our English language, one of our letters, A, B, W, Z, whatever you want to use. A letter used to represent a value that can change. Okay? So, a letter used to represent a value that can change. So X doesn't get to be the same value all year long, in other words. If we choose X, X is not going to always be the first thing we ever solve X to be. It's going to be whatever it is in that situation. Okay, whatever it can represent in that situation. It can change from situation to situation. Okay, so some examples. Typically, here are the ones they typically choose, and you will probably get in the habit of choosing X as a variable that you're going to see a lot, used a lot. And notice I wrote it kind of in cursive. That's kind of what they do, like in italics when you're on the computer in Word, italics. That's cursive. You're writing it and you're putting it in small. Typically, it's written in small case, lowercase. Y is another typical one used. A, B, C, and
sometimes I use the T, which is like not.
Yeah, and even how many letters do we have in the alphabet? 26 of them. Yeah, but some of them might be not good choices. It doesn't mean that the book doesn't choose to use them sometimes. Like Mrs. Krebs just said, sometimes she chooses a T, but why would T possibly not be such a good one to use? It looks like what? Well, which number does it look like? Kind of like a 7, depending on how you make your T, right? What operation symbol could it possibly pass for? The addition sign, right? Yeah. And especially if you're not writing it in italics, in cursive, if you're not writing your T, it might possibly be mistaken for an addition sign instead. So some of them we like to just stay away from if we can, but we have all kinds of options. Okay, a constant. Anybody think they've got the definition down for constant yet? Notice I didn't have you open your book yet because I thought maybe you would have some of these memorized already. No? Constant. If something is constant, it does not do what? It does not change. Yeah. Okay, so a value that does not change. A value that does not change. If someone tells you they're going to give you $5, does it matter necessarily how they give it to you? You can get it all in quarters. You can get a $5 bill. You could get, what's another way?
5 ones.
5 ones. What's another way possibly? You could get
500.
500 pennies, yeah. So there's lots of ways to get $5, but $5 is $5, isn't it? If somebody tries to only give you 3 $1 bills and they say they're going to give you $5, you can let them get away with that? No, probably not. You're going to be like, hey, wait, you owe me $2 more. A constant is a constant, it does not change. Okay, so let's give some examples. Like, would 5 be a constant then? Pi would be a constant. Can you give me any other examples of something that would not change? Now let's be creative, okay? Let's be creative. Can you think of some other numbers that really actually live on the number line, even though they're not showing here, they're not labeled here? Can you think of some other numbers that live on the number line that their value really never changes? It may be represented different ways, but it never changes. Its value never changes. Zero, okay. Zero is a constant. Even though lots of times when we get zero for an answer, we're like, I must have done something wrong, because you're thinking I can't get zero. Zero's offended when you do that, by the way. Zero is a value. It's kind of nothing value, but it's a value. It's a number on the number line. Give me another one. Be creative.
Pi.
Pardon?
Pi.
Pi. Oh, that little character like this. This is, that Greek symbol pi. Does anybody know what number pi is, so that we can kind of know where it lives on the number line? 3.14 and da-da-da-da. In fact, there's a poster back there for pi. Does pi's digits ever stop? No, they go on forever and ever and ever. Do they ever have a repeat pattern? No, pi is actually what we call one of the irrational numbers. It lives on the number line, but it never changes. Even though it never stops and it never repeats, it never changes. Pi is pi. Okay? And give me another example. How about something that does maybe have a decimal, but it doesn't actually stop? Or maybe it even repeats. Okay, I'll help you out. How about 1/2? Is 1/2 a constant? Yeah, it doesn't change. If you get half of something, that's half. Okay? Half of $1 is how much? 50 cents. No matter what form you get it in, you know what 50 cents is, don't you? Or maybe let's even use a decimal. How about if we have 0.75? Is that a constant? 0.75 a constant? Sure it is. 0.75? It doesn't change if you, again, I like to use money law because for some reason our world is kind of revolved around it. We understand it. 75 cents. If somebody's going to give you 75 cents, are there a variety of ways they can give you 75 cents?
Yeah.
Absolutely. Yeah, 3/4 is one of the ways. So a constant, it does not change, okay? Numerical expression, anybody think they've got that definition down yet? This was one thing that, not only with this class, but all throughout the day, any class that took some sort of a pretest on this material did not understand what an expression was versus an equation. Anybody think they know the difference, first of all, between an expression and an equation? Anybody think they know that difference? Okay, let me tell you. Equation. If it's an equation, it has an equal sign in it. If it's an expression, it does not. If it's an expression, it does not. So an equation actually is made up of expressions. It has an expression on this side, an equal sign, and another expression on this side. Well, now those expressions, whether they're not part of an equation or they are part of an equation, there are two types. There are the numerical type and there are the algebraic type. So a numerical expression is a mathematical phrase These are your notes for you to use to help with homework, to study from, to use on quizzes. Make sure you're making them useful. A mathematical phrase that contains, so what's it made up of, in other words? That contains only constants, you know that thing we just defined up there, only constants, and or, in other words, it can have something else, or it doesn't have to have a constant, it can just have this other thing. You can have either both of these things or just one of them, and or operations. end a sentence. So a mathematical phrase, and the reason I say phrase is because it's kind of like a sentence in English. It's not a sentence, it's a phrase. Give me a phrase in English, just a phrase. But, you know, if you said that, people would need more information. By the water. Is that a phrase? Sure. By the water. What do I mean by that? Well, until I put it into a sentence, it makes no sense. It's a phrase. It's a part of the sentence. That's what an expression is. It's part of an equation. So, a mathematical statement, or phrase I mean, that contains only constants and or operations. So all of those constants we just listed up above, they're actually numerical expressions. Let's give some other examples of some numerical expressions. So let's give me a numerical expression that only has a constant. Throw it out. Throw it out. Give me a numerical expression that has only a constant in it. You're going to have to do this in your homework. Come on. Oh, yeah. Oh, golly. Why? You guys don't tax my brain so much. Help me out here. Come on. 4, thank you. That's a numerical expression. Now, give me one that has, well, by the way, if it has to have operation, if it has operations, it's going to have constants. So anybody help me out with a numerical expression that has both things going on? How many mathematical operations are there? Taking out your kidney, fixing your kneecap. Are those mathematical operations? No. What are mathematical operations? Addition, yeah, plus. What's another one? Subtraction, what's another one? Multiplication, what's another one? Are there any others? No, those are the only 4. Those are the only 4 operations in math. So now give me a numerical expression with constants and operations in it. Or operation. It doesn't have 2 operations or 3 or all 4. Oh, this is just really not that hard. Come on, go for it. 3 plus 6, would that be a numerical expression? Constants, and it's going to be the operation of addition. How about 2 pi? Or in other words, when you put 2 next to a symbol, put a new constant next to another constant or next to a variable without anything, what operations going on between 2 and pi? Anybody know? Multiplication. So this really means 2 times pi. So we have 2 constants, 2 and pi, and they're being multiplied. Okay. I'm going to give you one last chance to try and give me one more. Somebody do it and be creative. Don't use one of these. Adam? Was that Adam?
Yeah.
I love it. -2 divided by 1. A constant divided by another constant. So the operation is division, and we have 2 constants involved in it. So do you think you have a good idea of what a numerical expression is? Okay, let's try an algebraic expression then. Okay? So an algebraic expression. You know what, I want to make this as easy as I can for you, but yet, I'm afraid that we might leave something out. So we're going to have to write out a big long statement again, but I'll try and explain it easier. So a mathematical phrase, it's an expression, so it's a phrase, not a sentence. A mathematical phrase I'm going to shorten it up. That must have a variable. Mathematical phrase. So it's like a numerical expression. It's a mathematical phrase, but it has to have a variable. Can the numerical have one? Was that part of the numerical expression's definition? Could it have a variable? Could, look back up at our numerical one. could it have a variable? It said constants and or operations. Was variable listed in there? No. So now we're saying, oh, but if you have a variable in it, now it's no longer a numerical expression, it took on a new role. It's called an algebraic expression. So numerical expressions can turn into algebraic expressions by getting a variable involved in them. Okay? So, anybody think they have an example for me of a algebraic expression? If you can come up with one?
5x.
5x, I love it. 5 is being multiplied times the variable x. So we have a constant in there, we have a variable in there, we have an operation going on. How about w? Just w. Would that be an algebraic expression? It's a mathematical phrase, there's no equal sign involved, it has a variable in it, it doesn't have a constant or an operation, but it doesn't have to. It just has to have a variable, doesn't it? Can you give me another one? Sam, think you can come up with one for me? Y, okay, so the variable y, just y by itself. How about we be a little bit more creative though when we do something with that y? Let's operate with it. Y times 6. Well, when we want to put it in this order, because we started with the y already, now we have to put a multiplication dot there and a 6 behind it, because if we don't put the 6 first, then we can't leave out the multiplication dot. Okay? And if you noticed on your pre-test, some of you who used the x for multiplying, what did I change it to? Dot. I took my purple pen and changed it to a dot for you. Okay? Okay. You already gave us one, Anna. Somebody else has to. Maisie, could you give us one, and then we're going to be done giving these?
Like a x with a 2.
X with a 2 or
X
x to the second power? Yeah, that would be an algebraic expression. Good job. Okay, so we have to have a variable involved. Can't have an equal sign because it's an expression. We can't have constants. We don't have to. We can have operations. Don't have to. We can have. This is another operation. What does x squared mean? What operation is really going on there? What does x squared mean? A number times itself. So there's multiplication going on, isn't there? This really means x times x. This is just the shortcut way of writing x times x. So there is an operation called multiplication going on. Okay, so that's our terms, and not only that, but we have some visuals now. We have some idea of what when I use those terms, or you do, or the directions in your homework does, you're like, oh yeah, this is what it's talking about. And you need to refer to that. Okay, words for mathematical operations. In other words, there's some words in the English language that should be like, oh, this is what they're talking about. This is what they want you to do. So for addition, can anybody come up with an English word or English phrase that would indicate to you the operation of addition is going to go on? Preston, can you come up with one for addition? A word or some words that would mean I better add. Can you help them out, Taylor? I'm kind of passing it to them. If you come up with one, you can lead them to the punch. Go for it.
Are you asking for a sentence?
No, I'm asking for a word or a word phrase that will indicate to you that you need to use the operation of addition. Seth, do you have any? Blake? Okay, you guys are making this way too hard. Let me search you out. Okay. You thought it was a trick question, didn't you? Okay, now are you ready to start giving me some? Okay, who can give you one? Blake. Add. Sum. But how do you spell that sum? S-U-M. The S-O-M-E in the English language does not mean add. It doesn't. The S-U-M does, though. That is, okay?
Total?
Total. There's lots more. There's so many more. Come on. Positive. Positive doesn't really tell you to add. Positive instead, what that does is it gives you the condition of the number. Where's it at on the number line? Is it to the right of 0 or is it to the left of 0? Okay, but good increased by? Could we use that? Increased by. Because you're gonna have to, you're gonna have to do this in your homework, and I want you to have all kinds, some options here. How about more than? Okay, so maybe you can find some more that you'll be able to add to this later. Okay, let's start with subtraction now. Subtraction. Minus. You guys caught on quick. Minus. And then did I hear somebody say something about less? Or 7. Decreased by. And we have to use the word by so that we can kind of give some order to it, because you know what? Subtraction is really fussy. Addition is not, and subtraction is. Subtraction says there's a specific order you have to subtract in. Because 10 take away 5 is not the same as 5 take away 10. Okay? Amazing. Less than. Subtract. I know, it's almost like that seems too easy. Could we really use that word? Sure we can. 9 subtract 4. Yeah. Any others you can think of? Take away. Pardon? Divide? Pardon? No, divide is a different operation. You can't use that word for subtraction. Okay, we have a pretty good list of them here, don't we? Okay. And you can add, we can keep adding to them when you're ready to. Okay, let's go to the back side, because there's a couple more operations that we gotta get some words for. Multiplication. Times. Go ahead and just name them out.
Squared.
Squared. Multiply. But typically what happens is we don't say 4 multiply 5. We say 4 multiplied by 5, don't we? Let's write it that way. Multiplied by.
For the word product, finding the product.
Product, yeah. When they tell you to find the product, that means you better multiply. Can you think of any others? Right now that we could add to our list. How about
Equation.
equation really means that we might have an operation going on in an equation. We might, and that operation might be multiplication, but equation tells us we better set up a mathematical statement that has an equal sign. It doesn't say anything about we have to multiply it. Okay, well, we can leave it at this for now. Okay, maybe you'll find some more in your book. Division. Division. Divide. Okay. I'm gonna put it here so that it doesn't look like I gave us a whole lot of room here. Divide. But do we say 4 divide by? How do we say it? We say divided by, don't we? Let's make this into divided by. Because we want to talk like we know what we're doing. What's the answer you get when you divide? What's it called? This is the cube. Quotient. Yeah. Quotient. If you're going to divide up some money amongst, what do? You split it up.
Half.
Split, pardon? Half. Okay, so you could say half of, that would be, divide, you would know if you saw it was half of, you would have to divide by what? 2, okay. And how about, could we put split into? I didn't mean for that to be a to split into equal groups. So, because of course your friends are going to make sure you're fair. If you're giving away $100 to 4 friends, then you got to split it into equal groups, not just split it. Okay, so those are some things that might indicate to us that we need to divide. Is division fussy? Uh-huh. Is 10 divided by 5 the same as 5 divided by 10? No. You have $10 divided amongst 5 friends, they're each going to get how much? $2. $2. If If you have $5 and you split it amongst 10 friends, anybody know how much they're going to get? 50 cents. Is it the same? How about multiplying though? What if I take 10 times 5? What do I get? 50. What if I take 5 times 10?
50.
I still get 50. So does multiplication care what order is? No. Does addition care what the order is? Is 5 plus 10 the same as 10 plus 5? 5 plus 10 is?
15.
10 plus 5 is?
15.
Addition doesn't care. So which operations care about the order that you do it in? Division and subtraction. Those are the fussy ones. Okay. Let's go to the bottom of page 6. Go to the bottom of page 6 in your books. Now we're going to practice so that you know how to do some of this in your homework. Okay? So 1A, where the check it out problems at the bottom, and the directions give us this. Give 2 ways to write each algebraic expression in words. So the first thing we're going to do is, I wonder how many times I'm going to do that this year. We're going to write down the expression that we're writing. That's the algebraic expression, right? It has a variable in it. So this is an algebraic expression. We're going to write that in words. We don't have to write a story, you guys. We just need to write this in words. So, what's one way we could write this? A word phrase that tells us this is what the algebraic expression of that word phrase would be. Amazing.
4 decreased by a variable.
And we can just say n, so we don't have to write the word variable. Okay, so 4 decreased by, and I'll let you, instead of writing the word 4, I'll let you write the number, okay? What I care about is that you can come up with the words. So we'll let the variable stay what it is, and we'll let the number stay what it is, but we're going to replace that operation with some words. So 4 decreased by n. I want us to challenge ourselves to using the word less than. How would we write it if we were to use the words less than? Pardon? N less than 4? Or 4 less than n. Remember, subtraction's fussy. Here, could we have written, in this one, could we have written n decreased by 4? No, because that would have been n minus 4. So less than is that's the tricky words one, and we have to know how to do it, because trust me, that's the one they want to challenge you on. It is like Adam said, when they use the words less than, the order that they're written here changes in the word phrase. It's n less than 4. In other words, it's telling you n is being subtracted from 4. N less than 4. Okay, let's do the next one where we have a t over a 5. Okay, t over a 5. Now that's not how we're going to write it, because over is not an operation. So we're going to put an operation. We have to somehow identify what operation is going on. It's a divided. Oh, so t divided by 5. Could we do that? Order matters in division, right? So we're saying the t is upstairs, and it is being divided by. So t divided by 5. That shows us this is how you should set it up. If you're going to write it as a fraction, because fraction bar means division, you would write t over 5, t divided by 5. Okay, I want to challenge you to using the word quotient. Quotient up. Is t the quotient of 5? No. Quotient up, let's write that. In other words, as soon as you see this, you're saying there's a division going on because they use the word quotient, and now I need to describe the parts of the division problem. And I have to worry about order. Not equals, we just put quotient of t and 5. We name the parts. So in other words, when we use the word quotient, which is the answer for division, when we use the word product, which is the answer for multiplication, when we use the word difference, which is the answer, we got that one in our subtraction words, difference of, when we use the word difference, that means the answer. Now we need the parts. What are the parts of the problem? T and 5. Okay? The next one is, look at that. Algebraic expression 9 plus a cube. We're not going to use that one as our words. That's too easy. Let's do this one. Let's do sum. How would we do sum? Sum of what? Sum of Q and 9. Okay. Could we do it that could we reverse the order like that? Sum of Q and 9. Notice we're not saying Q plus 9 because the sum already tells us that we're going to add. We don't have to say it twice. We only need to say it once. So sum of Q and 9. And notice they're not. We didn't say them in the order they were in the problem. Why didn't we? Do we have to? No. Addition doesn't care. Okay, so we could have said sum of 9 and Q, or we could have said sum of Q and 9. Okay, now I want you to come up with another one. Remember, I don't want you to use the word plus. Try another one. Sam, got one for me? Okay, Blake's going to help you out. 9 increased by Q. 9 increased by Q. 9 increased by Q. And our last algebraic expression, 1D, we have that 3, and next to it in parentheses is an H. Amazing. Product of 3 and H. I like it. Could we have said the product of H and 3? Yeah, multiplication is not fussy. Maybe another one. Is that yours, Andrea? Or did you have a different one? I thought your hand was make that up another one. Preston, can you come up with one for me?
H is multiplied by 3.
Okay, H is multiplied by, and now we're kind of making it into a sentence. We could leave the word is out, by the way, if we wanted to, but we can leave it in there. H is multiplied by 3. Could we have said 3 is multiplied by H? Sure we could have. Multiplication isn't here. Okay, so here we're practicing changing algebraic expressions into our English language, basically. How would it be stated in the English language when they give it to us algebraically? Okay, and then in number 2, we are practicing going in the opposite direction. So let's write our objective here first. We are translating from words now to algebra. So now they give it to us in the English language, and they say, okay, mathematician, show me how to write this algebraically. And we're in the middle of the page. Lou drives 2A. Let's put that first, 2A. Lou drives at 65 miles per hour. Write an expression for the number of miles that Lou drives in T hours. So we know how fast he's going. They say the number of hours is measured as T. How could we write an expression that would represent how many miles he'll go? We got speed and time. Anybody know what you do to get distance? Because they want an expression to represent how far they'll go. You take how fast you're going times how long you drive. What does that tell you? So if I drive at 70 miles an hour for 2 hours, how many miles am I going to go? Really? You don't know? If I drive at 70 miles, I cover 70 miles every hour, and I drive for 2 hours. 140. You multiplied there, didn't you? You took 70 times 2. Well, we don't know what the time is. Our time is represented as T, and we're driving 65 miles per hour, so how would we write that algebraic expression? 65t. We would say 65t would give you how far you're going to go. 65t. So here we didn't write down the whole thing from the book, so you'd have to refer to your book here to get what is this representing. 2b. Let's skip a line so they're not on top of each other. We have Miriam, who is 5 centimeters taller than her sister, who is m centimeters tall. In other words, we don't know how tall she is, so we're going to let m stand in for her height. But we do know that Miriam is 5 centimeters taller. Write an expression for Miriam's height. Remember, she's 5 centimeters taller than her sister. Write an expression for Miriam's height. How tall is Miriam? 5 centimeters tall? So did it say she is 5 times taller than her sister? What did it say? What keywords in there help us decide which operation? What keywords in here help us decide which operation we should use? Miriam is 5 centimeters taller than her sister. What operation should that be? Add. We need to add in this case. So what algebraic expression could we write? M plus 5, or 5 plus m. Doesn't matter. She doesn't care. So m plus 5. And you notice we're not putting labels on these. We don't have to worry about the labels right now. We're just getting the algebraic expression that would show how do we get Miriam's height. Okay? And then the last one, we have Elaine, who earns $32 per day. Write an expression for the amount that she earns in D days. Go ahead, write one down with your pencil right now. Try one. Because you can erase it if you're wrong. Try one. Everybody put for 2C. We're on 2C. You're going to write an expression that represents how much money Elaine will earn in D number of days, and she's making $32 a day. She doesn't have to work a really long day. Okay. Share, you three share and see if any of yours compare. You guys share with each other, you guys share with each other, you two share with each other. Let's see if you compare. Let's convince ourselves who's going to offer the correct answer here. Okay, who feels like they have the answer for us? They're convinced that, you know what, after talking with somebody else, you're like, I got this, Sam? 32D. How many of you agree with Sam? It's 32D. You are, those of you that are agreeing with 32D, or that's what you wrote, you are absolutely correct. Number of days, D times how much money every day, right? We multiply in this case. Okay, so that's the end of our note taking for today.
Put it in yellow pen.